On March 27, 1989, a room full of Soviet engineers on the Crimean Peninsula sat waiting for a signal that was already overdue. 400 million kilometers away, in orbit around Mars, their spacecraft had just performed what should have been a routine maneuver. It rotated to photograph one of Mars's two small moons. To aim its cameras, it had to swing its main antenna away from Earth and fall silent for a few minutes. The engineers expected that. They knew almost to the minute when the signal should return. The minute came. The signal did not. About 4 hours later, something finally arrived. But it was wrong. It was the garbled, broken kind of pulse a spacecraft sends when it is no longer pointed at anything at all, when it is tumbling helplessly through space. That faint, distorted transmission was the last thing anyone on Earth ever received from the probe. It had crossed the entire solar system to reach Mars and to slip closer to one of its moons than any machine before it. And in its final minutes, circling the red planet, it captured a photograph. What that photograph showed, and what made the spacecraft fall silent at the exact moment it turned to look, became one of the strangest and most disputed episodes in the history of spaceflight. Let's find out what was actually out there. The spacecraft was called Phobos 2, and it carries a distinction most people don't know about. It was the final interplanetary probe the Soviet Union ever designed. To understand why that matters, you have to understand how long the Soviets had been away from Mars. After a string of disappointing Mars probes in the early 1970s, the political leadership had largely lost patience with the red planet. The results weren't impressive enough to justify the enormous cost, and the funding dried up. But the scientists never stopped thinking about it. At the Space Research Institute in Moscow, known by its Russian initials IKI, a group of researchers kept turning the problem over. They knew that to return to Mars, they needed an idea compelling enough to change the leadership's mind. By the end of the 1970s, they had one. The idea was this: don't go to Mars itself, go to its moons. Mars has two, and they are tiny. The larger is called Phobos, the smaller Deimos. What made Phobos so attractive wasn't only the science, it was the orbit. Phobos circles Mars on a path a chemically powered spacecraft could actually reach without too much difficulty. It was, in a sense, the easy door into the Martian system. And targeting a moon instead of the planet carried one more advantage that mattered enormously in 1980s geopolitics. It let the Soviets do something the Americans hadn't done, rather than repeating something they already had. In early 1985, the government approved the mission, with public announcements following that March. Here is where the human story begins, and it explains everything that follows. The man running the Space Research Institute at the time was a physicist named Roald Sagdiv. His institute had just pulled off the Vega missions, an international effort that had sent Soviet probes past Venus and on toward Halley's Comet in 1986. It was a triumph, and it had placed Sagdiv and his scientists firmly in the spotlight. According to Sagdiv himself, that spotlight created a problem. The leadership of the Soviet rocket industry resented the attention the scientists were receiving. So when the Phobos project was organized, overall control was handed not to the scientists who had conceived it, but to the ministry responsible for building the rockets. In practice, the manufacturer got to dictate terms to the customer. The people who would fly the mission no longer fully controlled how it was built, and there was one more pressure, the one that would haunt the entire story. By the Institute's own estimate, a project this complex needed 6 or 7 years to do properly. They were given 3.5. Remember that number, because it comes back. Yet, for all the rush and rivalry, this was also a hopeful project. It arrived precisely as the Soviet Union was beginning to open to the world, and it became one of the largest international science efforts the Soviets had ever attempted. Scientists from 14 countries contributed, from both sides of the Iron Curtain: Austria, Bulgaria, Hungary, Finland, France, Sweden, the United States, both German states, and institutions of the European Space Agency among them. That openness went remarkably far. In 1987, before either probe had launched, the Soviets displayed full-scale models of the Phobos spacecraft at an air and space show in France. In the final days before launch, Western visitors were invited to tour the Baikonur Cosmodrome itself, including an Apollo astronaut and a delegation from the US Air Force. The old reflexes hadn't entirely vanished. Rank-and-file soldiers were still ordered to swap their uniforms for civilian clothes when foreigners visited, to disguise the military nature of the site. But the direction was unmistakable. This was the Soviet space program trying to step into the light, which is part of what makes everything that came next so painful. Phobos 2 did not fly alone. It had a twin. The plan called for 2 identical probes, Phobos 1 and Phobos 2, launched a few days apart in July 1988, both bound for Mars. The logic was redundancy. If one failed, the other would carry the mission. Two spacecraft, two chances. Phobos 1 lifted off first, on July 7th. For the first weeks, it behaved beautifully. It made its course correction, switched on an X-ray telescope, and photographed the sun, capturing well over 100 images of the solar corona and even catching a solar flare in the act. Then, on September 2nd, during a routine communication session, Phobos 1 simply didn't answer. Here's what happened, and it is one of the most quietly devastating facts in the history of spaceflight. A controller on the ground had sent the spacecraft a long string of commands, a routine package meant to keep the probe stable during an upcoming gap in communications. Somewhere in that string of code, a single character was wrong. One missing digit. Let that sit for a second. Not a hardware fault, not a collision, not a cosmic ray frying a circuit, a typo. That missing digit changed the meaning of the command. Instead of doing what it was supposed to, the code reached into the spacecraft's memory and triggered an old test program. A routine written to check the attitude control system on the ground, which, because there hadn't been enough time before launch, had never been erased from the spacecraft's memory. The test program ran, and the very last thing it did by design was switch off the attitude control system. So that is exactly what Phobos 1 did. 11 million kilometers from home, it shut off the system that kept it oriented. With nothing holding it steady, the spacecraft drifted, slowly nudged off axis by the faint constant pressure of the solar wind. Its solar panels turned away from the sun. The power faded. The batteries emptied. After weeks of trying to revive it, the Soviets declared Phobos 1 lost in early November. The mission had lost half its fleet before reaching Mars. Everything now rested on the second probe. Phobos 2 was built on a brand new platform, a full generation's leap beyond the old Venus probes. At its heart sat a ring-shaped instrument compartment atop a powerful propulsion unit fed by 8 fuel tanks. That propulsion design was so good, it would later live on as a rocket stage called Fregat, which still flies today. But the most important part of Phobos 2 for our story isn't the engine, it's the brain. The spacecraft was controlled by 3 identical onboard computers, working on a principle that sounds almost democratic. For any decision, the 3 computers would effectively vote, and the spacecraft would do whatever at least 2 of the 3 agreed on. The logic was sound. If a stray cosmic ray flipped a bit and made one computer briefly malfunction, the other 2 would outvote it. 3 brains, majority rules, no single point of failure. Hold on to that idea. The mission plan was extraordinary. Phobos 2 would enter a wide orbit around Mars, then gradually tighten it until it circled in step with the moon Phobos itself, eventually flying in formation just 35 kilometers above the surface. Then came the part that made this mission unlike anything before it. Once it had mapped the moon, Phobos 2 was supposed to descend until it hovered just 50 meters above the surface. Not landing, hovering. Landing on Phobos is nearly impossible because the moon's gravity is so feeble that a hard touchdown would simply send a craft bouncing back into space. While hovering, it would fire a laser at the surface, vaporizing a tiny puff of soil into a glowing cloud, then read the light from that cloud to determine exactly what the moon was made of. A way to taste a world without ever touching it. Finally, it would release landers. One designed to hop across the surface on spring-loaded legs, another built to fire a small harpoon into the ground to anchor itself to a moon that barely wanted to hold anything at all. To point its cameras at Phobos, the spacecraft had to turn its body, and turning its body meant swinging its main antenna away from Earth. Every close look at the moon required the probe to stop looking at home. It had done this before, more than once, without trouble. Just file that away. Phobos 2 launched on July 12, 1988, 5 days behind its doomed twin. Almost immediately, it began to show the strain of the rush it had been built in. Remember the 3.5 years versus the 6 or 7 the scientists said they needed. This is where that shortfall started to bite. During the long cruise to Mars, things began to fail. By the time Phobos 2 reached Martian orbit, its 3-computer brain had quietly become a crisis. One of the 3 computers was completely dead. A second was beginning to fail. Now go back to the voting rule. The spacecraft does whatever 2 of 3 computers agree on, with 1 healthy computer and 2 failing ones. The single working computer was outnumbered. It could be entirely correct, and it wouldn't matter, because the system was built to trust the majority, and the majority was now the failures. A safeguard designed to protect against a single failure had, through sheer attrition, turned into a trap. And it wasn't only the computers. The high-speed transmitter meant to pour data back to Earth had developed its own problems, forcing the probe to trickle its findings home at a fraction of the intended rate. The spacecraft had crossed the entire inner solar system and arrived at Mars already wounded, already dying by degrees. And yet, remarkably, it kept working. It entered orbit around Mars on January 29, 1989. It built a thermal map of the surface, photographed the planet in visible and infrared light, and studied the atmosphere. Its science kept flowing slowly through a half-broken transmitter controlled by a brain one bad day away from being unable to vote itself out of disaster. By early 1989, a crippled spacecraft, the last hope of an entire program, was circling Mars and slowly closing in on a tiny moon. Its handlers knew it was failing. They knew the clock was against them. They decided to push forward anyway, because the alternative was to have come all that way for nothing. The final close approach was scheduled for April 7th. The probe just had to survive a few more weeks. So it began photographing the moon in stages, like a camera slowly pulling focus. On February 21st, it imaged Phobos from roughly 1,000 kilometers away. A week later, from 300 to 400 kilometers. On March 25th, from less than 300. Each pass closer, each image sharper, a potato-shaped little world resolving out of the dark, scarred with craters and strange parallel grooves, swelling larger in the frame. In total, across its short life at Mars, the probe sent home fewer than 40 images of Phobos, some resolving features just tens of meters across. For a dying spacecraft trickling data through a damaged transmitter, that was a genuine scientific haul. Then came March 27th. Phobos 2 was scheduled to make another imaging run, to turn and face the moon for a fresh series of pictures. To do that, exactly as before, it had to point its body at Phobos, swinging its antenna away from Earth. You already know what happened. The spacecraft went quiet for the imaging session as planned. The session ended, and the probe never cleanly returned. 4 hours later came that faint, garbled, indecipherable signal, the signature of a spacecraft tumbling out of control, unable to hold itself steady or aim its antenna home. A tumbling spacecraft can't keep its solar panels in sunlight. By early April, the temperature inside would fall to freezing. By mid-month, it would be too cold for anything to function. On April 14, 1989, with the probe surely frozen in orbit around Mars, the Soviets declared the mission over. Here is the strange part, the part that turned an engineering tragedy into a legend that refuses to die. When investigators later tried to explain the loss, they could agree on what the spacecraft did. It tumbled, lost power, and froze. What they could not fully explain was why it started tumbling in the first place. That initial push, during the few minutes the probe had turned away from Earth, remained. In the words of one detailed account, a mystery. Officially, blame settled on human error somewhere on the ground, as it had with Phobos 1. Other explanations circulated. A failure of the attitude control system, a loss of the transmitter, or a final breakdown of that ailing flight computer, which had been showing signs of trouble for months. That last explanation is generally considered most likely. But notice the word likely. There has never been a single definitive public failure report that closes the case. Into that open question, the stories came rushing in, and here we have to be careful and honest about what is fact and what is not. The most famous claim came from a remarkable woman named Marina Popovich. She was a Soviet test pilot, one of the best the country ever produced. They called her Madame MiG. In 1964, she became the first Soviet woman to break the sound barrier, and over her career, she set more than 100 aviation world records. After the Soviet Union collapsed, she became one of the most prominent voices in the Russian UFO movement. At her public appearances, she would display a photograph she said was the last image taken by Phobos 2, claiming it showed an unexplained, elongated cylindrical shape near the spacecraft just before the transmission stopped. So what do we actually have? We have a heroic but controversial figure, presenting an image and a story. We have a spacecraft that really did die suddenly, never fully explained, while turning to photograph a moon. And we have a public hungry to connect those two facts. Let's separate the threads. The spacecraft really did photograph something. It photographed Phobos, a real, moving, dark little world crossing in front of Mars. The probe's final frame really was an image of Phobos taken from less than 200 kilometers away. That part is completely true. The claim that the image showed an artificial object, however, is attached to one person with no confirmation behind it. And the claim that Moscow deliberately cut the transmission to hide a discovery runs straight into the most boring and most likely explanation of all. A spacecraft built in half the time it needed, flying on a brain that could no longer outvote its own failures, finally losing its grip during a routine turn. But there is a grain of truth buried in the conspiracy. Moscow did not cut the transmission. The spacecraft died on its own. What Moscow did was something quieter and, in its way, more revealing. When the failures were discussed in May 1989, The head of the team that built the spacecraft tried to blame the loss on outside forces, the kind of bad luck no engineer could be held responsible for. According to those present, his arguments were met with open ridicule by the Institute's own scientists, while the foreign partners watched the Soviets argue among themselves. The old guard wanted to keep systemic problems in-house and pin any failure on meteoroids or radiation. The scientists who had flown the mission wanted an honest public investigation because they believed the real problems had to be admitted before they could ever be fixed. So when people say Moscow covered something up, they are half right and half wrong. There was no hidden photograph of anything unexplained, but there was a deep instinct in the system to reach for an external villain rather than confront a failure of its own making. The thing being concealed wasn't a secret in the sky, it was a flaw on the ground. There is, however, one genuinely strange detail in this story, and it has nothing to do with the supernatural. It's about the moon itself. Phobos is barely like a moon at all. It's small, only about 22 kilometers across on average, and lumpy, irregular, shaped like a potato. Its gravity is so weak, less than 1,000th of Earth's, that it never pulled itself into a sphere. It races around Mars in roughly 7 hours, so fast that from the Martian surface it crosses the sky in the wrong direction. Its dominant feature is a vast crater called Stickney, about 9 kilometers wide, taking up nearly half of one face. Whatever carved out Stickney very nearly shattered the moon. Back in the 1960s, a brilliant Soviet astrophysicist named Iosif Shklovsky looked at Phobos and noticed something that bothered him. For its size, the moon seemed too light. Its density seemed too low. Shklovsky floated a startling thought in the popular press. What if Phobos was so light because it was partly hollow? And if hollow, perhaps even artificial? It was a wild idea, but it came from a serious scientist, and it stuck. For decades, the notion drifted through the culture. So by the time Phobos 2 fell silent while staring at the moon, the cultural ground was already prepared for a mysterious interpretation. There's even a real object on Phobos that keeps the story alive: the Phobos monolith. A single large boulder roughly 85 meters across near the edge of Stickney crater, casting a long, sharp shadow. In low-resolution images, it looks oddly upright and out of place. But science has a calm answer. When something smashed into Phobos hard enough to blast out Stickney, it would have flung enormous boulders across the surface. The monolith is almost certainly one of them, a chunk of debris frozen in place on a low-gravity world. It looks strange mostly because our cameras can't quite resolve it, and a blurry rock often reads to the human eye as something too regular to be natural. But here is the honest twist that survives all the debunking. Shklovsky was wrong about why Phobos is light, but he wasn't wrong that it is light. Modern measurements confirm Phobos really is less dense than solid rock should be, most likely because it isn't fully solid at all, but a loose, porous pile of rubble full of empty space. And we still cannot say for certain where it came from. Some scientists think Phobos and Deimos are captured asteroids. Others think they formed from debris blasted off Mars in a colossal ancient impact. After all these years, we still don't know what the moons of Mars actually are. As a final footnote, the instruments on Phobos 2 searched the moon for any sign of water before the end. They found none. Phobos 2 was the last interplanetary probe the Soviet Union ever designed, and the system that built it didn't outlast it by much. Within 2 years, the Soviet Union collapsed, and planetary exploration funding collapsed with it. A later attempt to fly a similar design, Mars 96, failed when its rocket fell back to Earth. Russia tried once more, decades later, with a probe called Phobos Grunt, aimed at the very same moon. And it failed too, stranded in Earth orbit in 2011. Add it all up, and you reach a sentence that sounds almost impossible. To this day, there has never been a fully successful mission to Phobos. We have flown past it, photographed it, mapped its craters, even filmed it from the Martian surface drifting across the sun. But we have never landed on it. We have never held a piece of it. The story, though, isn't quite finished. Right now, a spacecraft is being readied by Japan with help from agencies in the United States, France, Germany, and Europe. Its mission is the one the Soviets dreamed of and never completed: to fly to Phobos, land on it, scrape up a few grams of that ancient surface, and carry them home. If everything holds, sometime in the next several years, a small capsule will fall through Earth's atmosphere, carrying the first piece of Phobos human hands have ever touched. Then perhaps, we'll finally learn whether it's a captured asteroid, the shattered child of Mars, or something we haven't imagined yet. Until then, the moon keeps its secret. It keeps racing around Mars every 7 hours, casting its long shadow, falling imperceptibly toward the planet that will one day end it. And somewhere up there, frozen and silent for over 3 decades, is a small Soviet machine that crossed an entire solar system to look at it, and got close enough in the very last moment to see the grooves on its surface before it turned away from us for good. We built the probe. We aimed it across 400 million kilometers of empty space. We watched it reach the one small strange world it was sent to find. And then, at the exact instant it turned to look, we lost it. And the dark closed back over the moon, leaving us exactly where we have always been. Standing on one planet, staring at another, holding a blurry photograph, and realizing how little we truly know about the small worlds right next door.